Okay, starting with number 1, which I feel is one of 10 or 12 of the most achievable ones. I have rewritten it because I usually don't do the quotient rule. I flip it up and do the product rule. Not everybody does that. Then if you do the product rule here, you will have 1 over x for the derivative of the front times the back the way it is, plus ln of x times the derivative of the back would be a minus x to the minus 2, I think. Stop me if I make a mistake, because if you haven't noticed, I've been trying to give people good attention points as half your grade, half your effort grade. This is going to be x to the minus 2 for this front part, I feel like, plus, no, minus x to the minus 2 times ln x. That's factorable, as product rules often are. Are any of these sort of like one of the answers? I feel like it's E. I think that one was doable. Do you feel like you have the capabilities, if that kind of hits you, you probably could do that? Maybe just did one little whoops? Well, I do those too. You've seen them every day. Number 2. How many points of inflection for y equals sine of x? Well, points of inflection, we're talking about concave up, switching to concave down, or vice. Oh,
Yeah.
that's. If I remember right, I've been rating Cody high in class attention. Sine of 2x. We got to do 2 derivatives on this, don't we? That's going to be cosine of 2x, but there's a fix, so it's like a 2, right? And then when you do the derivative of that, you're going to get negative sine of 2x. We already had a 2, and then we throw in another 2. Won't it be like that?
Can you move it up a little bit?
Ooh.
Give him a good concentrate.
So you see that these aren't hard derivatives. We should be able to do that. Should be able to handle that. And this speaks of concavity, and we're kind of wondering when that would be concave up and when it would be concave down. And we're only caring about 0 to pi halves. Thinking about the unit circle and the sine of 2x. 0 to pi halves is just going along here, isn't it? The sine just goes from 0 to 1 there, doesn't it? So I feel like all the way through that whole stretch there, the sign is positive. Doubling it makes you go 0 to pi. But it's still positive for that whole stretch. So we're finding the sine of 0 all the way to the sine of pi. Everything is the sine. This is always positive, and this makes it always negative, and this makes it 4 times as negative. So I feel like y double prime always negative from, they were talking about 0 to pi halves. Well, an inflection means you have to switch from positive to negative or negative to positive. There's no switches happening in that stretch. So I'm thinking that's got to be choice E. The concavity does not change in that stretch.
Mr. Board, I have a quick question. So
That's good.
sine, I always get confused on the circle deal, what sine and then cos are.
Oh, you're talking the unit circle thing?
Yeah, so like if sine is 0, then where?
Sines are heights, and cosines are like the x's. So right where you start here, the cosine is 1 and the sine is nothing.
Okay.
By the time you get up here, the sine is 1 and the cosine is 0. When you get over here, the sine is getting smaller down to 0 here, and the cosine is negative 1. Moving on to number 5. I feel like 3 is quite challenging. 4 is a little bit challenging, but 5 is quite doable. How many of you got number 5? 5, I believe, was C. All right. See if you think this is learnable. Well, 5 goes with that graph. So they want the value of the f of t. Which of these integrals is the f of t from 2 to 4? Can you see that does a quarter circle? And then a x is somewhere beyond. So we should draw a little line here signifying that we're going beyond to some x that we don't know. So the integral from 2 to x isn't even one equation, but it's going to amount to this area and this area put together, and this one is negative, am I right? This area is geometrically calculatable. That's a quarter circle. So right here I'm doing 1/4 pi r squared, and the radius of that looks like it's 2. Thank you, just lay that there. So then I want to go minus this area right here. Well, that's just a triangle. Triangles are 1/2 base times height. So I'm going to go 1/2 base times height. This triangle's top part right here is however far you are past 4, that's how big that base is going to be. So it's just going to be x minus 4. This appears to be running at a 45-degree angle here, this straight line. So won't the height of the triangle be the same thing? So I'm just going to put that right in the height spot there too. So this should be the same as the area you get when you do an integral from 2 to x. If you integrate this, and we don't even have the equation for that, but if you did it, it should be the same. It should be the same as the area under here and here put together. It should end up matching this. And this simplifies, I think this 4 and this 4 cancel. So that's pi minus 1/2. Is there one that looks like this exactly? Well, that'd be C. We should take C.
That you
didn't think I even corrected them.
Okay. Someone
Okay. So you may,
did.
you,
I'll show you after.
okay. So not only do you have good attention today, you probably are a lot smarter than you thought last week too. Okay, that's good, that's good.
What does that where x is greater than 4 mean in the question?
Well, I think the reason for that is this is x minus 4 if x is off to the right. Now, if x is off to the left of 4, then then the problem doesn't even make sense. So you have to assume that x is off to the right of 4. That's all they're saying.
Oh.
X has to be off to the right here as pictured. Good question. I think 6 is quite challenging. We didn't do a lot of work with advanced limits. 7 is doable, but kind of long. I could certainly help you with that one if you're trying to find your mistake. 8, I feel like we should put that on our short list. So let's do number 8 next. If you're trying to do the integral of 9x e to the 3x squared plus 1, does that say? Man, I don't know if I barely even read that. All right. If you're going to integrate that, this is the kind that sort of looks like you would need the product rule if you were doing a derivative. So for integrals, when we're trying to do a product rule backwards, that's when we do that let u equals thing called substitution. So we should let u equal something. And the key to picking the right thing for you, you want the derivative of u to match something in the problem that you're not substituting for. So I'm looking that, I'm thinking that the derivative of u would have x's. If we just let u be that, you'll see even better what I'm saying in a second here. Because if you let u equal that, then du could be 6x. You know? So then we can start doing our replacement here. Right now there's a dx over here, I believe. And then we would rewrite this as a e to the u. And you would replace a dx with a du over 6x, right? And then we have this x over here, and we have a 9. Well, that's nice. In fact, it's necessary that we cancel away the unreplaced stuff, else we can't do it that way. So we can change this to the integral of 3/2 e to the u du. Now, how do you do the antiderivative of a e to the u? Doesn't it just turn into e to the u?
Can you take the camera down
Then you're going to get a plus c, of course, right? Now it's time to put your u back in after you integrate. So your answer is going to be 3/2 e to the 3x squared plus 1 from, oh, we didn't even have to go any further, did we? They didn't even give us, they didn't even give us limits on it. There's nothing there and there, so this is the answer.
We have to do the fix for 3x squared plus 1.
We took care of that right here.
That was actually really easy.
So I guess I feel like that one's pretty doable.
What letter is that?
Looks like E is the answer. The next one I feel that is easy enough for just about everybody to understand here is 10. I was surprised more people didn't get 10 right. Oh, it has a twist in it though, it was nasty. Has a little trick in it. Thank you. All right, if that's the distance or position, then you know the first derivative of that is velocity. That'd be 3t squared minus 10t plus 2. And they wanted to know it at t equals 2. So then you put in a 2 there. You're gonna get 3 times 4 is 12 minus 20 plus 2, so you get negative 6.
Oh, that is a D move.
That's not the answer.
That is so me.
What are they doing?
It's a
That's for speed, not
come
velocity.
on.
That's such crap.
Don't
We have
I do not.
if we
You
put
should
that
not be
in-
yelling at me.
That is so me.
Why is this on me?
You.
So the velocity is equal to that. That means the speed is 6.
Can we have half credit if we put 6? Or
You can't have
negative
negative
6?
speed. You can't have negative velocity.
Mr. Moore,
No.
can we have full credit?
Are you getting quarter credit for that?
It's not my call. They wrote the test. They said they gave you both choices.
That's just stupid.
That's really hard.
I should add another point on that.
12. Number 12. So I take it then you feel that one's achievable and they'll never catch you on that again.
Yeah, my little sister could have gotten that one.
Dude, I got 12 right.
So that's really hard.
Well, I don't think we should sail past number 11 either.
Number 11 is so easy. Come on.
I feel like 11 is quite easy.
Come on, guys.
11 is not easy for me.
11 is so easy for everyone.
Are you ready? On this number 11 here, if A was correct, that would mean the slope is always y minus x. Well, then right at the origin, it would be 0 minus 0 or 0. The slope is not 0 at the origin. And I feel like you can do the same thing for this one, and this one, and this one. At the origin, all of these slopes should be 0, right? 0 squared, 0 minus 0, 0. That would be a level line there for a slope of 0, wouldn't it? So all 4 choices are bad except this one. You got to pick B. It's the only one whose slope at the origin is 1 plus 0. And then if there were other that fit, you should check them at a couple other spots, but you only have to check this at the one easiest spot to check. Number 12. Twelve is the integral from 1 to 6 of x plus 3 to the 1/2. I think that would be going up to a 3/2, wouldn't it? And then don't you have to always put a 2/3 here so that this times this gives you the 1 they have there?
Yeah.
Now you can't be doing that unless the fix is a nice clean 1, which this one is. You can't be anti-derivating things that have a fix, but this one really doesn't have a fix. The fix is 1, so we can do it. We can do it. So it's just gonna be an x plus 3 here, and we don't have to do an unfix, because the fix was uneventful. So the answer is really this, from 6 to 1. All we have to do is sub in a 6.
Yeah, you do 6 to the, can you do 9 to the third halves power?
Yeah, I suppose that's the tricky part. That isn't even the part I taught you.
That's where I got stuck on, what?
Yeah, me too.
I'm like, I can do that. Even though I'm pretty sure that's a good way to do it. Oh, it would just be the square root of 9 cubed.
So it's the square root of 9 cubed, so that's just 3 cubed plus 2 cubed.
The square root.
Oh, so you could just square it first and then put the cube on?
Yeah, you can do it in either order.
Cool.
You can do the cubed first and then the square root, or this seems like the easiest order for this one.
That's garbage.
81.
I'm looking.
That is garbage.
No, 27.
That is such garbage. What is 3 cubed plus?
Because you put the 1 in
Oh, I see what you did.
for x, so it'd be 1 plus 3. Equals 4.
Mr. Moore,
Yeah,
on the 9 and the 3 over 2 plus 4, it should be 3. Shouldn't it?
No.
No, that's wrong.
I feel like the only thing I did wrong is this is a minus.
Yeah.
Good catch, bro. Bro.
Did I catch that in time?
Wait a sec, bro. I don't think I did, bro.
Minus?
No, bro, it's not minus.
That's a plus.
It's supposed
Bro,
to
that's a
be
plus.
And that
It's
four
a
is supposed to
minus.
be.
Why is it a plus?
It's a minus.
You put in the 6,
Because you have to
You get
subtract the
this.
integrals from each other.
then you put in the,
Actually, what he's doing,
then you put in the 1, and you're supposed to subtract the answer that you get here, right?
a little bit of a headache.
All
I
right.
think that you're almost right, Mr. Moore.
Almost right?
Yeah.
That means as soon as I'm done, I'm right.
Right.
All right. So 27 minus 8, I think, is 19, so I think it's 2/3 times 19. That's 38 over 3. Do we have that option?
Yeah.
Please choose D.
Please choose D. That's garbage.
Is that where we're stopping today?
Yeah.
That's a good start.
I'll show you a few more of those tomorrow.